Hey everyone, and welcome back for another deep dive. Today we'll be exploring open source physics at Singapore, or OSP at SG. You sent us some pretty interesting source material, and it seems to give us a little bit of a behind the scenes look at this project. Everything from its goals and its impact to even how it was showcased at an innovation convention way back in 2016.
Yeah, these sources are really fascinating, almost like a time capsule. They really highlight the innovative spirit behind OSP at SG and how it really aimed to make physics education more engaging and accessible,
Mm.
especially in a time when mobile technology was really just starting to sort of boom.
Okay, so before we get into all the cool features, let's just start with the basics. What exactly is OSP at SG?
Okay, so in a nutshell, OSP at SG is basically a collection of open-source interactive physics simulations, ebooks and apps.
Okay.
It's designed to complement real-world experiments and to help students visualize those abstract physics concepts. You know, the ones that can sometimes feel intimidating.
I see. So instead of just reading about projectile motion in a textbook, a student could actually use an OSP at SG simulation to launch a virtual ball and adjust the angle and change the force and see how those changes impact the trajectory in real time.
Yes, that's exactly it. And the beauty of it is that these resources can be accessed on various devices, from computers to smartphones.
Oh, wow.
So it makes learning much more flexible and convenient. And remember, this was 2016, so having readily available mobile learning resources was quite forward-thinking.
Yeah, so they were ahead of the curve. Now, I'm really intrigued by this emphasis on student-centric pedagogy that keeps popping up in the source material. Could you break down what that actually means for those of us who aren't education experts?
Sure. So student-centric pedagogy, it's basically an approach that shifts the focus from the teacher lecturing at the front of the classroom to the student actively engaging with the material. In this model, students are encouraged to explore and experiment and discover knowledge through hands-on activities, and OSP at SG provides the tools for that. It's all about empowering students to learn like real scientists.
So that makes a lot of sense. And speaking of learning like scientists, I noticed that mathematical modeling is another key theme in these sources. Is this where things start to get a little more complex?
Not necessarily. Think of it this way. Mathematical modeling is simply using math to represent and understand real-world phenomena. In the context of OSP at ST, it means students can build simulations based on mathematical equations. They can manipulate variables and observe the results.
Mm-hmm.
So, for example, they might model a falling object and adjust its mass or the height from which it's dropped. And then the simulation would show them how gravity and air resistance affect its descent.
Okay, so instead of just memorizing formulas, students are actually using them to explore and test ideas, like taking those equations off the page and bringing them to life.
Exactly. And this hands-on approach can really lead to a much deeper understanding of the underlying physics concepts.
Now, one thing that really stood out to me was the sheer variety of topics covered by OSP at SG. The popular tags list mentions everything from basic concepts like fractions and 3D shapes to advanced subjects like quantum physics and nuclear physics. It's quite a range.
Yeah, it really speaks to the project's commitment to catering to diverse learning needs and interests. Whether you're just starting to explore physics or diving into more advanced concepts, OSP at SG offers resources to support your journey. And this connects to another important aspect highlighted in the materials. OSP at SG's global reach.
Right. The source material mentions schools involved not only in Singapore, but across Southeast Asia and beyond. It seems like this project really took off internationally.
Absolutely, and that's largely because OSP at SG is built on the principles of open source software and open data.
Oh.
These resources are freely available for anyone to use, adapt, and even contribute to, fostering a global community of educators and learners.
That's remarkable. So it sounds like OSP at SG is breaking down those geographical barriers and making quality physics education accessible to students worldwide. Now, the source material we have seems to be prep notes for a booth at a public service convention back in 2016. What can you tell us about that?
Well, the convention called PS21 ExCEL was all about showcasing innovation in the public sector. The fact that OSP at SG was even presented there really speaks to its recognition as a groundbreaking initiative, one that could benefit the community. It's a clear signal that the Singaporean government saw the value in supporting and promoting this project.
So it wasn't just like a passion project by a few physics enthusiasts. It actually had official backing and was seen as a significant contribution to public service.
Exactly. And the details about the booth itself offer further insight into how they wanted to present OSP at SG to the world. They plan to have all these interactive elements, allowing visitors to experience the simulations firsthand. They even mentioned having apps available for offline use. So they were demonstrating their commitment to accessibility even in a time when mobile data wasn't as ubiquitous as it is today.
Oh, wow. It's like they were already thinking about how to reach students in every possible context. Now, these notes mention a specific location for the convention, the Taeng Soon Convention Center in Singapore. But there's also this funny little aside. No wonder Google cannot find this.
It's true. And I think it's just a little reminder that even as OSP at SG embraced cutting-edge technology, there were still aspects of its development and presentation that relied on more traditional methods in physical spaces. It adds a touch of humanness to the story.
It is a nice reminder that behind every innovative project, there are passionate people working hard to bring their vision to life, even if it means navigating some logistical challenges along the way. So we've got this picture of OSP at SG as this innovative, accessible, and globally impactful project. But what did it actually look like in action? What kind of experience did they create for visitors at their convention booth?
Well, the interactive elements for the booth section provide some pretty tantalizing clues. Imagine, walking up to this booth and being able to try out these physics simulations on your phone or tablet. You could launch virtual projectiles, explore electric fields, even delve into the world of quantum mechanics, all through engaging interactive experiences.
It's like stepping into a physics playground. They even mention live demonstrations of how to edit the source code. Were they encouraging people to not just use the simulations, but actually tinker with them and contribute to the project?
Absolutely. That's a key aspect of the open source philosophy. They weren't just showcasing a finished product. They were inviting people to become a part of the OSP at SG community, to collaborate, share ideas, and really help shape the future of the project.
It's like saying, hey, here's this amazing tool for learning physics, and by the way, you can help make it even better. That's a pretty powerful message. Now, we've talked a lot about the tech and the big ideas behind OSP at SG, but I'm curious about the people involved. Did the source material mention any of the key individuals who helped make this project a reality?
They did. They list several OSP experts, including Professor Francisco Escombre, Fuquan Huang, and Wolfgang Christian, to name a few. And what's really interesting is these individuals come from very diverse backgrounds and institutions, both within Singapore and internationally.
So it wasn't just a local effort, it was a collaboration that brought together some of the brightest minds in physics education from around the world.
Precisely. And their willingness to share their expertise and work together to create these open source resources really speaks volumes about their commitment to making physics education more accessible and engaging for everyone.
It's a reminder that great things can happen when passionate people come together and break down those traditional barriers of knowledge sharing. Now, this peek behind the scenes at the convention booth has given us a sense of OSP at SG in its early days. But I'm curious to know, how did this project evolve? What impact did it have on students and teachers?
That's a great question, and one that we'll delve into as we continue our deep dive. Stay tuned as we explore the lasting legacy of OSP at SG and its contributions to the ever-evolving world of physics education. Okay, so far we've established that OSP at SG was this groundbreaking project that tried to make physics education more interactive and accessible. But did it actually work? Did it actually make a difference in how students learned?
Yeah, that's the million-dollar question, right? Like, we can talk all day about innovative features and cool simulations, but ultimately what matters is whether this approach actually helped students grasp those sometimes elusive physics concepts.
Right, and while the source material doesn't give us specific data on student outcomes, it does give us some clues about the project's potential impact.
Right.
Like, for instance, remember the emphasis on student-centric pedagogy and
Yeah.
mathematical modeling?
Yeah.
Those aren't just buzzwords. They're rooted in solid educational research.
Could you maybe elaborate on that a little bit? I'm curious how those principles translate into actual learning benefits for students.
Okay, so student-centric pedagogy is really all about shifting the focus from passive learning to active engagement. When students can interact with the material, experiment, and test their own ideas, they're more likely to develop, I think, a much deeper understanding. And OSP at SG, with its interactive simulations and hands-on activities, provides the perfect platform for that kind of learning.
So instead of just memorizing formulas or listening to lectures, students are actually getting to play with the concepts and see how they work in different scenarios. It's learning by doing, right?
Exactly. And that's where mathematical modeling comes in. By building simulations based on mathematical equations, students aren't just, crunching numbers. They're using math as a tool to explore and understand the the world around them.
Okay, I think I'm starting to see how this all kind of fits together, but I'm still wondering, is there any evidence to suggest that this kind of approach actually leads to better learning outcomes?
Well, there's definitely a growing body of research that supports the effectiveness of active learning and inquiry-based approaches in science education. While we don't have specific data on OSP at SG's impact, it's reasonable to say that by incorporating these principles, the project likely helps students develop a stronger grasp of physics concepts and probably even improve their problem-solving skills, maybe even fostered a greater appreciation for the subject.
So it's not just a hunch. There's actual science backing up the idea that this kind of hands-on interactive learning can be really beneficial for students.
Yeah, and while it's important to acknowledge that every student learns a bit differently, OSP at SG's approach offered a really valuable alternative to traditional teaching methods, potentially reaching students who might have struggled with, I think, more passive learning environments.
Now, you mentioned earlier that the source material that we have is from 2016, and technology has evolved a lot since then. So I'm curious, is OSP at SG still around? Has it kind of kept up with the times?
That's a good question. And while we don't really have access to the most up-to-date information on the project's current status, it's worth noting that the open source nature of OSP at SG makes it inherently adaptable and sustainable.
What do you mean by that?
Well, because the source code is freely available, anyone can modify or update it, or even just create new simulations based on the existing framework.
Mm.
So this means that even if the original developers are no longer actively involved, the project has the potential to live on and evolve through the contributions of a much wider community.
So it's like a living, breathing project that can continue to kind of grow and adapt as technology changes. That's amazing.
It is, and it really highlights one of the key benefits of open source educational resources. They're not tied to proprietary software or platforms, which can become obsolete or even inaccessible over time.
Now let's talk about the practical side of things. We've talked about the pedagogical principles and the potential benefits for students, but how do teachers actually use OSP at SG in their classrooms?
Well, the source material doesn't delve into specific classroom implementation strategies, but we can maybe make some educated guesses based on what we do know about the project. For example, teachers could have used the simulations as demonstrations during lectures, allowing students to actually visualize concepts in real time.
That makes sense. It's like bringing the textbook to life, making those abstract ideas much more concrete and engaging for students.
Exactly. Teachers also could have incorporated the simulations into hands-on activities, and that would allow students to experiment with different variables and then observe the results firsthand.
Oh, I bet that was much more fun than just solving problems on a worksheet.
I think so.
Yeah.
And the fact that OSP at SG was accessible on mobile devices meant that students could even continue exploring these simulations outside of the classroom
Yeah.
at their own pace and in their own time.
So it's like extending that learning experience beyond those traditional boundaries of the school day.
Yes.
Now, one thing we haven't talked about yet is the role of the teacher in this kind of learning environment. Does OSP at SG replace the teacher, or does it simply provide them with new tools?
That is an important question.
Mm-hmm.
And while technology can definitely, enhance the learning experience, it doesn't replace the role of the teacher. In fact, OSP at SG likely made the teacher's role even more crucial. Well, think about it. With students engaging in more active inquiry-based learning, teachers would need to facilitate those explorations, guide discussions, and provide really individualized support. So they would become less like lecturers and more like facilitators, really helping students kind of navigate the complexities of physics and just make sense of their own discoveries.
So it's not a matter of technology versus teachers. It's about finding ways for technology and teachers to work together to create, I guess, a richer and more engaging learning experience for students.
That's exactly right. And OSP at SG, with its flexible and adaptable platform, provided a framework for that kind of collaboration.
Let's shift gears for a sec and talk about the broader implications of OSP at SG. We've discussed its impact on students and teachers, but what about its contribution to the wider world of physics education?
Well, OSP at SG definitely represented a pretty significant step forward in the Open Educational Resources Movement, or OER. By making these high-quality physics simulations freely available, the project really helped to democratize access to learning materials and reduce reliance on those really expensive textbooks or proprietary software.
So it's not just about making physics more fun or engaging, it's about making it more accessible to students from all backgrounds and socioeconomic levels.
Yes, that's a key part of it. And by promoting that open source philosophy, OSP at SG really encouraged a culture of sharing and collaboration within the physics education community. It inspired others to create and contribute their own resources, further expanding that pool of freely available learning materials.
It's like creating a ripple effect of innovation and knowledge sharing, which benefits everyone, not just students in Singapore or Southeast Asia.
Precisely. OSP at SG's legacy extends far beyond its geographical origins. It really served as a model for other open source education projects around the world, demonstrating the power of collaboration and technology to, transform how we teach and learn physics.
Now, we've talked a lot about the positive aspects of OSP at SG, but were there any, challenges or limitations to this approach?
Well, of course, no project is without its challenges. And one potential concern is the issue of quality control. With open source resources, anyone can contribute. So that means there's a risk of inconsistencies or even errors creeping in.
Yeah, that's a really valid point. How did OSP at SG address that concern?
Well, the source material mentions the project had a team of OSP experts who reviewed and curated the materials. This suggests that they had some system in place to ensure a certain level of quality and accuracy.
So it wasn't just a free-for-all. They had a process for vetting the contributions and maintaining the integrity of the project.
Right. Another potential challenge is the need for, technical expertise. Not all teachers are comfortable working with code or modifying simulations.
That's true. So how did OSP at SG make these resources accessible to teachers with different levels of, tech skills?
Well, the project offered these pre-built simulations and apps that could be used as is without requiring any coding knowledge. They also provided documentation and tutorials to support teachers who wanted to delve a little bit deeper into the more technical aspects.
So they really tried to cater to a wide range of users, from those who just wanted to plug and play to those who were really interested in customizing the simulations to fit their, specific needs. That's really impressive.
It is, and I think it speaks to the project's thoughtful approach to making these resources as accessible and user-friendly as possible.
Now, as we wrap up this part of our deep dive, I'm wondering, what are the key takeaways for our listener? Why should they care about OSP at SG, even if they're not a physics teacher or student?
I think OSP at SG offers valuable lessons for really anyone who's interested in the future of education. It shows the power of technology to enhance learning, the importance of open access to knowledge, and the potential of collaboration to really drive innovation.
Yeah, it's a reminder that learning doesn't have to be passive or confined to traditional settings. We can explore complex subjects like physics in really fun and interactive ways at our own pace and from, anywhere in the world.
Exactly. And OSP at SG shows us that even complex subjects like physics can be made fun and approachable, inspiring a whole new generation of learners to explore the wonders of the universe.
We've covered so much in our deep dive into OSP at SG, from its innovative features and pedagogical approach to its impact on students and teachers. But I think what's really stayed with me is the passion and dedication of the people behind it.
Yeah, the source material may focus on the technical aspects in that convention showcase, but you can really sense that human element woven throughout. These weren't just developers, they were educators who really believed in the power of open source physics to transform learning.
Right. And they weren't just talking the talk, they were walking the walk. Remember how they included those live demonstrations of source code editing at their booth?
Oh, yeah.
That's not something you see at just any tech presentation.
Definitely not.
Huh.
I think it speaks to their commitment to transparency and community involvement.
Yeah.
They really wanted to show people that OSP at SG wasn't this black box, that anyone could understand how it worked and contribute to its development, and even adapt it to their own needs.
Yeah, it's like they were saying, hey, we're all in this together. Let's make physics education awesome.
Exactly. And I think that collaborative spirit is what really sets OSP at SG apart. It wasn't just a top-down project driven by experts. It was a community effort that embraced input from teachers, students, and anyone who is passionate about physics education.
Yeah, that's what I find so inspiring about this project. It reminds us that even in a field as complex as physics learning can be collaborative, joyful, and accessible. But I'm curious what happened after that convention. Did OSP at SG continue to evolve?
Well, unfortunately, the source material we have only gives us a snapshot in time. But we can make some guesses based on what we know about open source projects. The beauty of OSP at SG is that its potential extends far beyond that 2016 convention.
So even if the original team moved on to other things, the project could still thrive because of contributions from a wider community.
Exactly. The open source model allows for continuous improvement and adaptation. Think about it. New simulations could have been created, existing ones updated with the latest research, and teachers from all over the world could have shared their modifications and lesson plans. It's like a living project with the potential to keep growing and evolving.
That's an incredible legacy, and it speaks to the power of open source education in general. It's not just about free stuff, it's about creating a community of learners and educators who share knowledge and resources and constantly push the boundaries of what's possible.
Totally agree. And it's also a reminder that innovation doesn't always need massive funding or institutional support. Sometimes it just starts with a small group of passionate people who are willing to share their work freely and invite others to join them on that journey.
So, what does all of this mean for our listener, the person who's been with us on this deep dive? What can they take away from the story of OSP at SG?
Well, I think it offers a few key insights.
Hmm.
First, it highlights the transformative potential of technology in education. We've seen how interactive simulations and open source platforms can really make learning more engaging, accessible, and personalized.
Yeah, it's a reminder that learning doesn't have to be passive or confined to traditional settings. We can explore these complex subjects like physics in fun and interactive ways at our own pace and from anywhere in the world.
Right? Second, OSP at SG really underscores the importance of collaboration and community when it comes to driving innovation. The project's success was largely due to the willingness of individuals from all different backgrounds to share their expertise and work together towards a common goal.
It shows us what's possible when we break down those silos and embrace a more open and collaborative approach to knowledge sharing. And finally, OSP at SG is a testament to the power of passion and dedication.
Absolutely. It reminds us that even small-scale initiatives can have a really lasting impact, especially when they're driven by a genuine desire to make a difference in the lives of others.
So if you're feeling inspired by the story of OSP at SG, what can you do? How can you apply these lessons to your own life, whether you're a student, a teacher, or just a lifelong learner?
Hmm. I think the first step is to just embrace curiosity and a willingness to explore. There are so many resources and so much knowledge available online, and much of it is free and open source. Don't be afraid to dive into subjects that interest you and experiment with different learning methods and connect with others who share your passions.
Yeah. It's about taking ownership of your own learning journey and realizing that education doesn't have to end when you leave the classroom.
Exactly. And if you're interested in supporting these open source education initiatives, there are tons of ways to get involved. You can contribute to existing projects or share your own knowledge and resources, or even just spread the word about the power of open access to learning.
We've all benefited from the generosity of others who have shared their work freely, so now it's our turn to pay it forward.
I like that. That's a great way to put it. The OSP SG project may have started in Singapore, but its legacy extends way beyond any geographical boundaries. It's a reminder that knowledge doesn't have any borders and that the pursuit of learning is a shared human endeavor.
So as we conclude this deep dive, let's leave our listener with a final, thought-provoking question. If you could create an open-source educational resource, what would it be and why? What knowledge or skills would you share with the world?
That's a great challenge to think about.
Yeah.
What are you passionate about? What unique perspective or expertise can you offer? Let your imagination run wild, and remember that the possibilities for sharing knowledge and inspiring others are endless.
On that note, we'll wrap up this episode of The Deep Dive. We hope you enjoyed exploring the world of open source physics and the really inspiring story of OSP at SG. Until next time, keep learning, keep sharing, and keep diving deep into the vast ocean of knowledge.